All right, now with an example with quadratic factors in the denominator. So we're going to do a fraction decomposition of x plus 4 over x squared times the binomial x squared plus 4. So right now the denominator is in its factored form. So when I write my partial fraction decomposition, please remember that x squared is technically a linear factor. It's x to the first being squared. The x squared plus 4, that's not a difference of perfect factors. We can't factor it. We'll leave it as a quadratic. So my fraction will equal capital A over x plus capital B over x squared. Those are the two linear factors. Plus, now my x squared, remember the power of 2 tells me I have to have two terms on top. A capital C times x plus a capital D. And again, if I don't need one of these, it will occur as a 0. All over my x squared plus 4. So again, remember, every denominator has to have the least common denominator, or our original denominator that we had. So looking at our first fraction, we have the x. You need another x, and you need the binomial multiplied to capital A. The second denominator just needs the binomial multiplied, and the second fraction needs the x squared multiplied top and bottom. So here's the x and the x squared plus 4 multiplied to the a, and then we have our common denominator. The b multiplied by just the x squared plus 4, because that's all that was missing on the bottom. And the cx plus d has to be multiplied by the x squared. That's what was missing. Now that all the denominators are the same, we don't have to look at them anymore. We just focus our attention on the numerators. We multiply it out. Ax times x squared is ax cubed. Ax times 4 is 4ax. B times x squared is capital Bx squared. B times the 4, 4b. Cx times the x squared will be cx cubed. And x squared times capital D will be dx squared. All right, now, again, collecting your like terms. There's no x cubed on the left, and there's no x squared on the left. So those are going to be zeros. So the ax cubed plus the cx cubed add up to be a 0. Again, these two have to be opposites of each other. For the x squareds, b and the d, there's no x squared on the left. Those two have to add up to be 0. These two will be opposites. X to the first, we have a 1 out in front there. So 1 has to be equal to 4ax. There's no other x term, so let's just solve for a right now. A is equal to 1/4. And our constant 4 is equal to 4b. And we can go solve for b right away. B is equal to 1. So as we said, well, a plus c equals 0, then c has to be a negative 1/4, and b plus d equaling 0, and b is 1, d has to be negative 1. So there's my back substitution, and here is my partial fraction decomposition. It's okay to put a fraction up in the numerator. Now, you might notice that on this last fraction, notice how both of these terms are negative. You might see the answer with both negatives factored out and change this plus sign to a minus sign, and then these two terms are both positive. It's 6 of one, half dozen of the other. It doesn't matter to me. I've also seen books who don't like to have fractions in the numerator, so they'll take this 4 and move it down to the denominator. And over here, they'll take this 4, move it into the denominator, but then you have to multiply the 1 as 4 over 4. We'll change the 1 to 4 over 4 so we can remove the factor of 4 in the denominator to the bottom. I've seen that done as well. Now, in terms of the author's modified zero product rule, The 0 here is going to be a problem. The 0 makes this into a 0, this into a 0, and yep, you can solve for b, but that's it. The 0 product rule, you cannot turn this binomial into a 0. It's impossible. So, okay, how do you cancel these out to solve for the other letters? The the modified 0 product rule, the only one we can solve for is b. You would literally have to let x equals 1, x equals 2, and x equals 3, and substitute those numbers in along with b equaling 1, and you would create a 3 by 3 system to solve for a, c, and d. So I think it's easier to multiply this out. Most of the time you get this back substitution where you can solve the system. If you don't, then go to your calculator and make a 3 by 4, 2 by 3, 4 by 5 if necessary, and do an RREF with the system that you create. And you'll have your answer. All right.